Hello, today we're looking at related rates. Okay, so let's see what questions we're asked to solve today. So for each curve, find the equation of the tangent. Oh, that looks a bit cut off. Oops, wrong color. The tangent at the given point. All right, so our curve is 5x squared plus y squared equals 21, and our point is -2, -1. Okay, so we need to find, what do we need to find first? We need to find the equation of the tangent at the given point. So general equation of a line, or tangent is a line, is y equals mx plus b. M is our slope, so we need to find the slope at that particular point. So why don't we do that? So how do we do that? We need to find the derivative first. So in this case, we have an equation involving x and y. So maybe we could use implicit differentiation. So we'll just differentiate all the way through the equation with respect to x. So we have 10x plus 2y times y prime. You need to use the product rule, and that equals 0. Okay, so we want to find the slope at this particular point, -2, 1. So we're going to plug in -2, -1 into our derivative here, our derivative equation. We have 10 -2 plus 2 times -1 times y prime, and then we're going to solve for y prime. So we got -20 minus 2 y prime equals 0. And then we can solve for y prime, and we get -2 y prime equals 20. Let's find a little bit more space. Let's make this a bit smaller. We can divide both sides by -2, and we get that y prime equals -10 at our point -2, -1. Okay, so we have our m value. So now we have y equals, all right, so this y is for the equation of our tangent. Tangent mx plus b, and we have the m equals -10 x plus b. So all we need to find now is b. So we can just plug our point -2, -1 into our equation and solve for x. So we have -1 equals -10 times -2 plus b. Let's solve for b. -1 equals 20 plus b. So b equals -21. Good. Okay, so therefore we're going to put it all together. And what do we get? Oh, we just have enough space. Excellent. Therefore, our line is y equals m -10 x minus 21. 21 is the equation of our tangent line. Okay, let's just leave that there. We don't need to write a sentence for that. Good. All right, next question. Okay, the side of a square is increasing at a rate of 5 centimeters per second. At what rate is the area changing when the side is 10 centimeters long? At what rate is the perimeter changing? Okay, so we got two questions here. Let's draw our square. So I always suggest, drawing pictures. So let's draw a little square. It's not that great. Anyway, all the sides are equal. Let's call a side x. So we're interested in the area and the perimeter. So let's just look at the area first. So the area of a square with respect to its side is given by x squared. And we're told that the side of a square is increasing at a rate of 5 centimeters per second. So the rate of change of the side with respect to time t is 5 centimeters per second. So we are asked, at what rate is the area changing when the side is 10 centimeters long? So we need to find the rate of change of the area with respect to time. So we need to find dA dt. Okay. So dA dt, we can use the chain rule, is dA dx times dx dt. Okay, we know what dt is. We can find dA dx. That's just 2x squared. And our dx dt is given to us. It's 5 centimeters. I'm not going to write in the centimeters per second, but it's 5 centimeters per second. Okay. So we have 10x squared, and they're asking us, oh, my mistake, I didn't take the derivative properly. The derivative of x squared is 2x. So we get 10x. We're asked what is the rate of, at what rate is area changing when the side is 10 centimeters long. So we're going to plug, when x equals 10, we get dA. The rate of change of the area when x equals 10 centimeters equals 10 times 10, or 100 centimeters squared per second. Good. Okay, that's the first part. Now, hopefully we have some space and we do the second part. Oh, actually, why don't we move over to the side, make it a little smaller again. Okay, so in the second part, we're asked at what rate is the perimeter changing? So what is the perimeter? Let's call it P. P equals the sum of all the sides. So for a square, it's 4 times x. Okay, and we have the same rate of change for a side. At what rate is the perimeter changing? Okay, so we need dp dt. Using the chain rule, this equals dp dx times dx dt. dp dx is given by 4. dx dt, we know that's 5. So it's 20 centimeters per second. So that therefore the perimeter is changing at a rate of 20 centimeters per second. So let's just write that down. Therefore, perimeter, let's see if we can, whoops. What? I don't know if I'm ever going to get used to this. Okay. Perimeter is changing at a rate of 20 centimeters per second. And we can make a closing statement for the first part. Therefore, the area, or I think they worded it as the rate of change of the area, the rate of change of the area when x equals 10 is 100 centimeters squared per second. Good. Okay, so that brings us to the end of our session today. If you have any questions, give us a shout at info@raisemymarks.com or give us a call day or evening, and we look forward to hearing from you. Thank you. Goodbye.